Welcome, future scholars!
Hello, ladies and gentlemen. Welcome back to my second episode. It's been quite a long time. I'm sorry about that, but I'm taking care of a lot of different things these days, so I kind of delay. My apologies. And before I start today's lecture, in the description down below, you can download a free HTML file that you can download on your PC or your Android. I think even the phone can support HTML type files. So if you download it and run it, you can see that what kind of open weights can be utilized to your own PC. So to utilize that fully, at least you have to understand the fundamental knowledge of open weights, which will be delivered in this lecture. So have fun. Let's begin. So today's lecture, we briefly review what I talked before. So in the last episode, I talked about what is my workflow, how I utilize my open weight, which is Gemma 4 27 billion parameters. And from my perspective, my own arena for image picture generation code bases was 88% acceptance from my experiences against, in the Hugging Face community, there is a GPQA diamond scoreboard, which is 67% for Gemma. But for my cases, it worked pretty well. So don't trust I'm not saying that the official SWE bench or deep SWE benches, those kind of things are not credential, but it can be vary based on your use cases. So you have to learn it by yourself. That was my previous episode. So today's main episode question is, so if you decided to try the open weights, what PC should you buy before you decide, which is very, very important. So this time, what it costs to start is the main question that I will explain from my use cases. Okay, so let me explain the open weight first. The open weight is like in the LM Studio or Llama, you download it by yourself and you store it on your local computer, and then you run for your workflows to locally ask those kind of questions. My cases, I'm using Gemma for 27 billion quantized to 4 bits, which takes about 16.5 gigabytes of storage. And remember these kind of numbers. Each of the open weights that is unloaded to the Hugging Face, and when you download it, that's the value of the storage takes exactly the same number is required for both VRAM and memory. Don't forget. I will explain later again about this. So my case is 16.5 gigabytes. But hey, you are running 16 gigabytes of laptop GPU by yourself. How do you manage that? I will explain those later too. So how the open weight models can live in your machine? You have to consider 3 different things before you buy certain PC. So if it doesn't matter if that's desktop or laptop. But here's the thing. Your GPU is the stage, your RAM is your backstage, and your CPU is the stage manager. So to open weights is something waking up in the LM Studio and you deliver a question, then open weight will do some like thinking or preparing to get your correct answer. Well, that kind of calculation and the speed of the answer is mostly based on the GPU itself. So as long as you have sufficiently enough GPU size idle, except for the basic fundamental storage that is required mandatorily for your Windows or Mac, whatever your platform you're running daily basis, at least 3.0 gigabyte is required to running your PC outside of open weight. So the rest of the GPU will be fully utilized to calculating fast. That's how GPU works. However, the RAM itself is required to 2 things. One thing is the token that you have to ask throw to your open weight to give a question, and whenever the agent is thinking and they taking the output as of an answer that you asked is going to be a token, and the token requires RAM memories. And even these days, like thanks to a lot of engineers who is working in the world, in the community, they developed various different types of things that reducing the GPU requirements for the open weights and share those memories to CPU or RAM. But the problem comes here. So even if you don't have enough GPU for RAM size, you can run some of the bigger models for your local PC with the quantization. But outside of quantization, what your PC can do is spilled over that kind of amount of VRAMs can be put it to the either RAM or CPU. But for the CPU cases, you need to run mixture of expert models only, which is running active parameters, not the entire thing, which is dense model. I will explain the details later. But your CPU can manage a little better than RAM. For RAM, when your spilled over free RAM goes to the RAM memory, then the entire speed goes like 10%. So it will just barely manage to create one word in few seconds, which is not desired, right? So let's say you have 16 bits of 45 gigabytes of your open weight, which is desired for your use cases. When you quantize it to 4 bits, then the memory size will go be 25%. So it's like 25%, 75% reduced memory that you put it into yourself. But the problem is the quality drops for sure. But here is the MoE that I talked here. It's a big library, but very few librarians resides there. So for Gemma cases, I'm using 26 billion parameters, but A4B means active only 4 parameters will be running with GPU itself. So 26 dense model is requiring 26 gigabytes of GPU fully loaded by itself. But your 4 billion parameters of agent requires very smaller size of GPU while it's running. So with that MoE, you can run the denser model. So what is denser model? We'll talk about it later in the few slides later. So when you spill over your GPU required RAM, which is called GPU offload, then spill that to the backstage or in the stage manager. But stage manager sharing with the GPU itself is only available in MoE. I think I'm going to explain those kind of things in the episode 3. Okay. And the context window is the thing that you have to think about, like per your own daily project, how many lines of words based on letter size or A4 paper, based on your country's formal size, how many tokens must be delivered on your query, on your certain works. That is determined, that is talked based on the context window. So lower context window, the faster the agent can answer your question, but the shorter conversation that you can convey or continue with that session only. So bigger context window is desired, but that requires more RAM memory as well. Okay, so cutting off all of the details about, we need GPU and CPU and RAM. So for 32 gigabytes DDR5 kit is 32 gigabytes. So like if you're running 16.5 gigabytes of Gemma, then the rest of the 10 gigabytes is required. The details of calculation will be deployed later, but this is something that's say to you that memory prices didn't rise, but they multiplied. So 32 gigabytes DDR5 kit last year, it was only $90. Now it's 4 times. Whereas the 1000 buys about last year, 2025 November, the RTX 5080, that GPU is rather goes down. So the memory prices goes way expensive these days. That's the problem that we got here. Also, the AI data center, why the memory prices goes up? Because, the bigger companies like Meta or OpenAI or Grok, XAI, and SpaceX, they bought their own company, right? And other companies as well. They need a lot of data centers, but those data centers, the deck of each of the PC itself using the same memory that we are using these days. That's why the memory price goes up like triple or quadruple, or even we are expecting like twice more than next year. So all of the consumers' money is wasted. So don't think about anything. Bigger model can do better job. It's not the stuff that you have to consider. Rather, you have to ask 3 things before you consider to buy what PC you want to. So before you buy the PC, what open weight I need for my base work? And is my work verifiable? And how long is my project? These 3 question list that you have to answer yourself before you decide to buy a certain specs of PC. So let me explain. The first question is, what do you buy or what do you want to promote to open weights? Most likely, we have 4 different categories that you can consider. What is open weights do better than the open frontier models? Frontier models, you pass your data, you pass your query, so that will be stored to the other companies' data sites, and those kind of data will be used for training purposes. So you are leaking your own strategy or your personal information to other company while you are using frontier models. But on your local model, like I was heard that in coming September, there will be like very light models of open weights will be officially launched to our phone as well. Like E2B or E4B, those kind of things, they're very small. Only 2 gigabytes of VRAM is required for daily base of works, those kind of things. So anyway, eventually you have to deal with open weights. So the open weight is privacy. It will run locally. Never ever your own data will be shared with other people. So it's safe. And you have unlimited amount of tokens. So for Fable 5 launched a few weeks ago, it was banned by US government, and now it's coming back only a week. Then you have to pay the API fees, databases based on your amount of work. So that's another problem. But with open weights, you can solve it. No costs, only billing for your electricity. And learning situation, watch your own VRAM fill. Nothing teaches faster, which means if you don't have to be urgent, if your work or your flow, your job is slow, and time doesn't matter, then open weight wins compared to frontier model. Frontier model is winning two things compared to open models, which is precision and time. But if you are not running out of time, why not using open weights? And ownership, it cannot be deprecated or repriced or taken offline by other people. Nothing. So it's free. That's how open weight serves for you. So the first question is, how are you going to use your open weights? And the second thing is your work deterministic or creative? So I was like a couple of slides ago, I was saying, is my work verifiable? So this is kind of deterministic versus creative. Let's suppose your major workflow with AI is like novelty something. You have to write a novel or poem, or you have to create something out of sand or from scratch. You have nothing to share with your data with your open weight. Then the agent itself is going to have to reasoning and thinking, then to be creative to give you the answer. But For creativity, the denser model, the higher parameters values a lot than the low parameter models. But if your major job is crawling the data from newsletters and or organizing your all the files, or you have to classify your figures, those kind of deterministic things, the answer is fixed. In that case, you don't have to raise your model to denser. Rather, that kills the tokens and it just spiral without exceeding the thinking mode, and it will not be able to give the correct answer for you because the thinking of creativity is getting collision with the deterministic answers. So for deterministic jobs, or if your work is verifiable by yourself, then don't waste your money too much on the denser model, just rather looking at the lighter models. Bigger models, thinking more is not something that it can swipe more your cards, or it doesn't classify your jobs better. It's nothing. That is coming from my experiences. Okay, so the real question is, can I catch its mistakes cheaply by human review? Then you're going lighter models. No denser model is required. Rather, for figures to fail silently in only 26 billion models, which is denser model, right? Which is heavier thinker. But rather, the 12 billion model with my checker beats the bigger models. That's from my experiences. So in my cases, the 12 billion parameter model was sufficiently enough to win the 26 billion model mixture of experts. That's how it's different. Deterministic versus creativity. The last question that you have to answer yourself is how long will be your project is. So as long as the duration of your project is less than a year or year and a half, then I would rather suggest using frontier models for your cases because your daily base is very light and it's just doing a frequent daily crawling the data from the stock market and newsletters, how the things going on out there. All of those kind of use cases can be done with very, very cheaply. But if your project is going to be forever, then I would rather recommend to purchase your own PC because the longer that your project is going, the more data will be stored in your PC. But if you don't want to leak your own personal data to the frontier models, then you have to consider getting your own hardware. However, if you just doing a deterministic job and if you're okay that your personal data is linked to the others, then go for the frontier models. Even Gemini 3.1 Pro takes only $20 per month. I think that's quite cheap. And also consider the hidden cost is your electric bills and the heat from the PC itself and your bedroom noises. If you have your laptop or desktop right beside your bed, then you're getting a hard sleep. Okay. So how the open weights model works on your PC. Like I said before, the amount of storage of the open weight itself, it already tells you how many GPU is required and how many RAM is required, only to just make it wakes up. Then the rest of the memory is required for the context window that you are going to throw your query and get the answer. So for 8 billion model, if it is quantized to 4 bits, around 6 gigabytes required for that specific case's VRAM. If you're running a model between 12 to 27 billion, which is going to be something multi-turn analytic workflow, then you have to consider about from 8 to 17 gigabytes. So 16 gigabytes graphic card is already enough for your cases, which is also for my cases. So if you want to run like 70 billion, like QN 3.5, 70 billion, or Gemma 35 billion dense model, okay, then you need 42 gigabytes of GPU itself, which is going to be really expensive. Anyway, you also have to consider about KV cache. So what is KV cache? The KV cache is key value cache memories. this is something developed recently that to prevent the context anxiety or context rot is what we call it in developers, which is sometimes, let's say, you talked a lot with Gemini frontier model, like 1 million tokens. You turn over like over 20 of the talks. You asked 20 times, the agent answered 20 times. Then the agent is starting to lose its memory to keep the agent working properly, to reducing hallucination, those kind of things. But what KV cache serves it is that it's outside of it. It is not in the context window. It is not in the GPU or RAM wakes up. It's totally outside of those kind of memories. But that very small KV cache will try to maintain the context that you threw and getting from agent itself longer than you expect. So with that, the agent will not forget what you asked for or the data that you provided. So you don't have to toss your data or the input or desired output or the 80 reference data that you are taking care of. You don't have to throw it frequently. That's how the KV cache works. So this one also requires the hidden memory. Let's say if we are running 70 billion parameters of model, then 0.11 gigabytes per 1,000 token is required, which means 128,000 context window requires around plus 14 gigabytes of memory itself. So that's also, you have to think about it. If that KV cache overflowed from your GPU and CPU, then 50 tokens per second will drop to 2 to 3 tokens per second, which is 25 times slower than your normal usage. So don't forget, KV cache is also there. You can also try that in the HTML file that I described at the beginning of the video. Feel free to download it. Okay, so from my perspective, from the last episode that I talked about is I'm running 60 gigabytes VRAM, and the leaderboard in GPQA diamonds, the Gemma 4 was only 67%, but my cases, it wins 88%. So even you are imagining certain open weights will suit your workflow, the more proficiently that you understand your workflow, then the better that you can imagine which open weights works better. Because I am a Korean mathematics teacher, I have to create Korean letters of the quizzes itself. So the biggest problem is which open weights can understand Koreans better. Even the Korean mathematics symbols, that was the biggest issue from my perspective. So it totally depends on what kind of workflow that you are designing with your open weights. So considering of GPU, what I recently found is if you are trying to purchase used RTX 3090 desktop, 24 gigabytes free RAM, which is around 75% of flagship speed, that is around $700. It's not cheap. Still, it's not cheap. It's not cheap. But anyway, if your work requires longer conversation, creativity writing, and a private co-pilot, then you have to judge your quality. That goes bigger models wins with the longer context, which requires more memory. So be careful when you choose your open weights before you buy your PC. So here's my recommendation of the final table. If you are going to learn about something, just to know you know nothing about what's quantization, what is KV cache, how the RAM works, how the open weights run for you. If you have nothing, then just simply download LM Studio right now on your PC if you have one. Even 8 gigabytes of free RAM can run 4 to 12 billion models. For like better running, maybe 30 tokens per second, which is that major people feel smoothly working, that AI is answering your question. It's about 7 billion parameters with 8 gigabytes of VRAM. So if for everyone, but before answer question 1 to 3, How long will it be your project? If your work is verifiable or not. If you are doing creative job, then probably lower models will not fit for your wish list. And what kind of open models that you want to? What do you want? What do you want from open weights? That is the top 3 questions that you have to answer for yourself. Then it goes up to something value. So the used RTX 3090 at 24 gigabytes is around 700 to 1,000 bucks, which is 1.1 million to 150만 원 in Korean. So that's what you have to taking care of in this second half of the 2026. So this is use case B, or proven daily habit from tier 0. But if you're committed and if you want to work better, then you have to spend a little more money on your cases. So be careful with your budgeting. So weights are free. Memory is the currency. That's the problem these days. But after memory's cost drops down, then electric bill will go again, and with the token costs, maybe there will be measurement of tokens per electricity bills in the future. That's what I'm thinking. Anyway, so ask your purpose first. Then consider if your job is verifiable or not. And if your job is verifiable by yourself, and if it is deterministic work with chip checks, then go smaller models. You don't have to go in longer models or bigger models or dense models. And duration. If your working duration is very short, I would recommend just to keep your money and work with the frontier models until the more lighter models with the more capabilities. Eventually, maybe within next year, Gemma 5 or GPT OSS better versions and even Grok-free models will be launched anyways because they want to survive. That kind of open sources will require lower VRAM as the technology evolves. So wait for yourself, and if your project is a short period, then simply use the frontier model. That's how you survive. Thank you for watching this video. And if you have gone so far, share with your friends, thumbs up, and subscribe to the channel, and you'll get more valuable resources from me. Really. See you guys later. Bye.
Thank you for subscribing. Check out these useful videos right here.